So we're going to go ahead and look at the first two questions on the homework. So the first one, we're just trying to graph this parabola. So we want to find its vertex, and this vertex will actually be on the y-axis. So you can't just use the y-intercept as your second point, but you can plug in any other point. So why don't we jump over and just sketch a little bit of it by hand. So if you have something that looks like y equals, basically it's minus x squared plus 8. I think they use t and k of t or something fancy, but we can just use y and x like usual. So my vertex, remember the x, it has two coordinates. The x coordinate is going to be negative b over 2a, so the x coordinate is, well, b here is 0 because there's no x term, so it's going to be negative 0 over 2 times negative 1, but that's just 0, right, which makes the y coordinate, if you plug it in, 0 squared plus 8, which equals 8. So our vertex is the point 0, 8. Well then, usually on the homework or the other examples I've shown, I've said just use the y-intercept as your additional point. Well, we can't do that here, so we have to plug in some other value. So let's plug in 1. We can plug in 1 and negative 1 if we just want to make like an xy table here. So if I plug in negative 1, I would get negative 1 quantity squared, so I'd get opposite of negative 1 squared plus 8. This would come out to 7. And if I plugged in 1, I would get negative 1 squared plus 8, which is also 7. So I have 3 points that I can graph, namely my vertex, which is 0, 8. Then I'll have 1, 7 on this side, negative 1, 7 on this side, and I get my parabola. So we just need to figure out how to do that on the graphing tool. So if you come over to WebAssign and look at that, basically you just select the parabola shape and then pick those 3 points. So we have 0, 8. So we want this one. So click on the 0, 8, and then this point right here, and it already does that one for you. The vertex we already said was 0, 8. It already has the parentheses for us, and then we can submit and see if we got it right. Which it looks like we did, because now we have the check marks. Number 2, it says write an equation for the given quadratic function. Give your equation the form y equals ax squared plus bx plus c. So they've basically given us 2 points, 1, negative 2, and 0, negative 4. So let's come back here. So the second one, we have, so the vertex, I believe is, what do we say, 1, negative 2, and the y-intercept is 0, negative 4. Let's go back and just check. Yeah, 0, negative 4, 1, negative 2. Okay, well, all right, we have the form y equals ax squared plus bx plus c. Well, one thing we know, c is the y-intercept. So we know this already looks like y equals ax squared plus bx minus 4. So that's one of the things taken care of. Now we can plug this in because we know the vertex is given by the equation x equals negative b over 2a, right? So we know 1 is equal to negative b over 2a. So we have a relationship between those two things. So we know that if we cross multiply, 2a is the same thing as negative b, or if we want b can be replaced by 2 minus 2a. If we move the negative to the other side, just multiplying or dividing by negative 1. Okay, so then we can take this equation and rewrite it as y equals ax squared minus 2ax minus 4. And we can plug in that point 1, negative 2 to figure out what a is. So negative 2 replaces y, and 1 replaces x. So we get a minus 2a minus 4. We can add 4 to both sides, so we get 2 is equal to minus a, which tells us that a is equal to minus 2. Well, if a is minus 2, that means b is going to have to be negative 2 times that, which is 4. So that means our equation, we have all 3 letters figured out, a, b, and c. So that tells us that y is equal to minus 2x squared plus 4x minus 4. And that is the equation in standard form. So we just really used that vertex formula in a different way. So let's go ahead and check that. So minus 2x squared, does not give me the exponent, squared plus 4x minus 4. And that is about it. And yeah, we got it correct. So that's it for those first two. So hopefully that helps out. This is Dr. Lennon signing off.